Hey everybody, here is a quick video on graphing rational functions. So what we've got here is a rational function x squared minus 6x plus 10 over x squared minus 2x minus 8. So one of the first things you want to do is you want to check the degree of the top and the degree of the bottom. In this case, the degrees are equal, which means you have a horizontal asymptote at y equals whatever the ratio of the lead coefficients is. So in this case, 1 over 1 or 1. So I have a horizontal asymptote at y equals 1. The next thing you want to do after that, and you can do some of these things in different orders, so that's okay, but you probably want to start by factoring. Factoring will tell you if the graph has any poles or any asymptotes, vertical asymptotes. So I'm going to start by factoring the numerator and factoring the denominator. And actually here, the denominator factors to x minus 4 times x plus 2. But the numerator doesn't factor. If you were to graph only the numerator, it wouldn't even have any real zeros. So the numerator doesn't factor at all. Those two factors I do have in the denominator, therefore, since they can't be canceled out, are asymptotes, vertical asymptotes. So those are going to be at positive 4 and negative 2. From there, we can also find the y-intercept by looking at just the ratio of the constant terms in the numerator and the denominator. So in this case, the y-intercept would be the ratio of 10 to negative 8, which is negative 5/4. So that's at negative 1 1/4. From here, since the numerator doesn't have any zeros, which you could figure out by doing the quadratic formula or doing b squared minus 4ac, or trying to factor and then getting really frustrated, since the numerator doesn't have any zeros, there's not really many more tricks that we're going to use. From here, you're just going to start plugging in values. So I kind of trust that you guys can do that on your own. When I did that, I got some of the following points. So at negative 6, there's one that's just above 2. And at negative 5, there's one that's at about 2.4. At negative 4, there's one that's at 3 and 1/8. At negative 3, there's one that's at like 5 and 2/7. And again, you're just doing this by creating a table. So you're just going to take x values and you're going to plug them in. And the ones that factor nicely are going to be a little bit easier to work with, and the ones that don't factor are going to be a little bit harder to work with. You should be getting rational numbers, though, because you're plugging everything into a fraction. So you should have fractions of integers. Now, there's not going to be anything for negative 2 because the asymptote, but at negative 1, I'll have negative 1, 2, 3.4. I already know 0. At 1, I'm at negative 5/9. You just kind of go along this way. At 2, you're at negative 1/4. At 3, you're at negative a fifth. At 5, you're at about 0.71. And at 6, you're at 0.625. So now the question is, what does the rest of this graph look like? And in general, graphs are going to start off near horizontal or slant asymptotes, and they're going to go towards either positive infinity or negative infinity at a vertical asymptote. So if you were to continue plugging in points, and you plugged in, for example, negative 2.1, which would give you a value over here, or negative 100, which would give you a value over here, you would get things that have that curvature that approaches the asymptotes. So towards negative infinity, our y value is going to approach 1, because that's our asymptote. As we get closer and closer to negative 2, our graph is going to approach positive infinity. The graph then swings around from negative infinity up through all these points that we plotted and back down. Now you do actually have to plug in points. I'll highlight this for you. You do actually have to plug in points over here to know if the graph is going to go back down to negative infinity, or to see if the graph is going to go up to positive infinity, because graphs actually can cross through their asymptotes and go up towards positive infinity. So you might use a calculator, a scientific calculator. You might, in your head, plug in something like 3.5 to see where the graph is going. And if it's going back down again, you know that it's going to approach negative infinity down here. And if it's continuing upwards, you have reason to believe that it's going to approach positive infinity. Calculus is going to give you some ways to tell more about that, but that's in the future. Okay, now this graph comes down from positive infinity. It drops below its asymptote, and then it's going to go back up towards the asymptote from underneath. And that's maybe a little severe, so it actually looks more like this. But it then approaches the asymptote from underneath. Okay? That's a pretty tough example. It takes a lot of plugging in, so you'll have to make a table. And you might even have to plug in things like 3.5 or 4.1 in order to see the direction at those asymptotes. I started with this one because this is pretty much as tough as it gets. It has no real zeros, and it crosses over one of its asymptotes, and its behavior is totally not obvious. So that's why I started with this one. Hopefully that is somewhat helpful. A lot of the work that you'll find in your homework will be a little bit easier, but hopefully that's a nice start. All right. Thanks for watching.